talked about, let's see. Yeah, we just talked about the Duggars. Right. So we talked about parallelograms, haven't we? So now we're going to talk about something that's not a parallelogram, and it would be a trapezoid.
Basically a triangle. Oh.
Actually, the trapezoid has a lot of similarities to a triangle, okay, and you'll see that today. Trapezoid, and we're going to talk about a thing called a kite. Okay, kite. Trapezoids and kites. Trapezoids. All right, let's talk about a trapezoid first. There's one, and there's one. Okay, if you remember what the definition of a parallelogram was, a parallelogram was a quadrilateral with both pairs of opposite sides being parallel to each other. Do you remember that? Trapezoid, it's like half of that. It's a quadrilateral with not both pairs of opposite sides, but what?
One pair.
With one pair, that's right. With exactly one pair. So that right there would be the pair. All right, so one pair are parallel, and the other pair of sides, opposite sides, are not parallel. Okay? It doesn't say at least one pair of sides parallel. It says exactly one pair of parallel sides. This side right here, the parallel sides, we call the base. Remember I said there's a lot of similarities to triangles? Yes? Okay, so you remember that too, don't you? We have base. You have a base of a triangle, and what are the other things of the triangle? You have how about legs? All right. We have legs of the triangle. Okay, so the non-parallel sides, you see that? The sides that are not parallel to each other are called the legs of the trapezoid. And we also have. Actually, let's not do that yet. Let's do that on the next one. This angle right here is called, since it connects a leg to a base, this would be, let's wait for, we'll say it. That's called a base angle. That's a base angle, and this is a base angle as well. Well, let's not, tell you what, let's wait for the next thing that I do. All right, forget the base angle thing. We'll talk about that in a second. All right, I think, and that's just a regular old generic trapezoid. Nothing special about it, really. All I'm looking for is the definition. Remember, the definition is exactly one pair of opposite sides are parallel to each other. That means the other pair of sides are not parallel to each other. Okay, you follow me?
Yeah.
Okay. Let's see if there's anything else. Okay. Let's move on to the next thing. Now remember we had triangles. We had all kinds of special types of triangles, but oops. Let me scooch over a little bit because I just happen to have one of these things. There we go. Now this is a trapezoid, but it's a special type of a trapezoid. And this is what I want to really get into today. It's a special type of trapezoid. Well, first of all, it's a trapezoid, so those two sides right there are parallel to each other. But look at this leg and look at this leg. What do you think might be true about those two legs? They're equal in length, so this is equal to this. So, David, say it again. Say it again. Isosceles, right. So it's isosceles trapezoid. Okay, it's an isosceles trapezoid. Again, very familiar to a triangle, isn't it? So if I have a triangle, two equal sides, it's an isosceles triangle. Well, if I have a trapezoid with the legs being equal to each other, not the bases, but if the two legs are equal to each other, then it's an isosceles trapezoid. Everybody got that? Now, what I was going to do earlier was this. Talk about these base angles. Look at this base angle, okay, because it's this leg to this base, and it's this leg to this base. Guess what might be true about those two? If this is an isosceles trapezoid, they're congruent to each other. So the base angles are congruent to each other. So let's just mark this, A, B, C, D. And so we would say what? Angle D is equal to angle C. What are the other two base angles, do you think? A and B. So A and B would equal each other as well. So I'll say angle A equals angle B. All right, so we know that side AD equals side BC if it's isosceles. We know the base angles are equal to each other. What's true about A and D? What if I compared A and D together? What would they be? They'd be supplementary because they're what to each other? Consecutive interior angles, right. Two parallel lines cut by a transversal, right? Remember that? Remember that stuff? So that's consecutive interior angles. So these two would be 180, these two would be 180. These two down here would be equal, these two up here would be equal to each other, right? And you know what they're going to do, right? They're going to put some numbers in here, and you got to figure out, look, if they just give you one of these angles, you should be able to figure out the other three, all right? Now, what's kind of missing that we did with a lot of parallelograms? Diagonals. Okay, so let's put a couple diagonals in here. Let me get rid of these angle symbols. Let's stick some diagonals in here. So watch. If I went to there to there. Now watch what I'm going to do here. Since I got this program, I can do this. I'm going to copy and paste that, and I'm going to rotate it. Yeah, I'm going to rotate it. Actually, reflect it about 90 degrees, like that. Okay. Now watch. All I did was copy and paste, didn't I? I didn't change the length of it or anything. And if I go from here to here, yeah, look at that. Okay. Those two diagonals are the same length, aren't they? So what's true about the diagonals of a isosceles? This only works when it's isosceles. It doesn't work with just every trapezoid, okay? Only isosceles. So if it's an isosceles triangle, what's true about it? The diagonal, what did I say?
Triangle.
Did I say triangle? Sorry. Trapezoid. Then the diagonals are equal to each other. Make sense? What other figure did we have the diagonals equaling each other? There was something else we talked about earlier. Do you remember what else the diagonals were equal? What is it? Yeah, square, but more general, a rectangle. That's right, because a square is a rectangle. So when you had a rectangle, the diagonals were equal to each other. Now, do the diagonals necessarily bisect each other on this? No, they don't. Not on a trapezoid. When do they bisect each other? On a... Yeah, but what's more general than a rectangle? Not just any quadrilateral. Parallelogram. Parallelogram. Okay, so the diagonals bisect each other on a parallelogram. They don't bisect each other on a trapezoid. Okay. Somebody asked me. Excuse me. Somebody asked me this in the other class. Is this triangle right here? We'll call this P. Is APD congruent to BPC? And I haven't really had any time to look at it and think about it any further than this, but it looks like they are. But if somebody could maybe do a little proof of this and maybe show me, well, we do know this and this are equal.
Yeah.
Is there any way else to show that these two? If somebody can do that for me and let me see it, I'd like to see that. Okay.
Oh, I know how to prove. Angle, side.
Well, angle, side. Right. If I could prove that this one and this one up here, how do I know that this is congruent to that? I don't know.
Aren't the diagonals?
So Joanna, there's something for you to do. Okay. Figure out for me why these two triangles are congruent to each other.
The diagonals are congruent, and so is angle A and angle B. So if they're congruent.
Well, you can have alternate exterior angles.
Well, you know the diagonals are congruent, but you don't know. I don't think we have anything in here where it says that like this and this are equal or this or this. I don't know.
Well, if you had AP to wait.
God knows.
Yeah.
I'll ask when it gets happen.
It might be in the book somewhere. I just haven't had enough time to look at it. But I'm sure we could probably figure it out at some point. But anyway, I would guess that one and that one would be congruent to each other. It's just a guess. I don't know. Maybe they're not. Now, I could almost definitely say that this one and this one are not congruent to each other. Wouldn't you agree? Right, because I don't know that these two sides are equal or anything. So I'm positive that these are not congruent. But these, they probably are. I'm just not sure how I can prove that to you. But that's good enough. Let's see what else we can say about this. Base angles are congruent.
It looks like a kite.
And it's isosceles. Trapezoid is isosceles if the diagonals are congruent. Okay, we just talked about that. And, okay, that's enough of that. Let's go back to our regular normal trapezoid. Oops. I don't think I saved just a regular trapezoid. I'll just have to make one up on my own. Now this is actually, yeah, wait, I'll make it smaller in a second. All right, there's a regular normal trapezoid. It's not necessarily isosceles. I'm going to make it a little smaller because I'm going to show you something here. Watch this. If I found the midpoint, I'd say the midpoint would be about right there, wouldn't it? Yep. And I found the midpoint of this other side right here, this leg. Let's see, about right there. Now, if I connected the midpoints, you see what I'm doing? I made the midpoint, so that and that are equal. And actually, Yeah, well, because we don't know those two sides are equal. So what am I going to do? Let's connect from here to here. Perfect. I love this program. So I couldn't do it that nice on the board. All right, so watch. I connected this midpoint to this midpoint. We call this thing something. We give it a name. We call it the mid-segment. Right, that's on a circle, diameter. Okay, we call this the mid-segment. What does the mid-segment do? It connects the midpoints, okay, of the legs of a trapezoid. You hear me? These are the legs of the trapezoid, and it connects them. Again, this is not necessarily a isosceles trapezoid, so you can have a mid-segment of any trapezoid. All right. Now, what do you think might be true about this mid-segment? Look at these three lines. This line, this line, this line. What do you think might be true about them? Well, we know these two are parallel, right? Yeah, that's right. That looks parallel as well, doesn't it? Okay, and they are. Okay, so all three of those are now parallel to each other. But here's something else that's kind of cool about this that I probably wouldn't have come up with on my own. Let me just show you this. Let's take this segment. I'm going to copy and paste. So that length is exactly the same as that bottom base right there. I'm going to take the top base, copy and paste, and I'm going to come over here, and I'm going to do this. Now I'm going to try to put it right there. There's a little bit of a gap, but that's pretty close. Okay, do you see that? I don't know. Do you want to?
Yeah.
Do you want to make them different colors or
Yes.
make that red? I don't know. Can you see it? On the screen, you might not be able to see it too well, but we'll make this one green. Okay. All right, so there you go. So there's the bottom one, there's the top one, right? So let's take this middle one, copy and paste, and we're going to put it right up against it. Does that look like it lines up pretty close? Okay. Now look, this black one doesn't equal the sum of those two. There's no way it would equal the sum of the two. But guess what?
Wouldn't that one and the other one equal that?
Watch, I'm going to copy and paste again. Okay, so watch. If I took this and put it right next to that, I'm close. Yeah, it's supposed to. Anyway, you get the idea. If I did this exactly right, and it's not quite exactly right, but it's close. What do you think? This long one right here and this one right here. This short one is how much of the whole thing? It's half of it, isn't it? Okay. Or you could say the whole thing is how much of the little one?
2.
It's twice as much, right? So let's do this. A, B, C, D. And let's go E, F.
EQ.
So now let's see. If I take the top and the bottom and I add them together, so if I take AB and add it to DC, all right, that's going to equal what?
2E.
Right, twice the mid-segment, twice EF. Or I could have written it another way. I could have written it what? 1/2 of AB plus DC is equal to what? EF. Make sense?
Could you write
All right, that's kind of cool, isn't it?
Could you write 2 parentheses EF so it can distribute?
Well, this is one thing. EF is not something you can distribute. It's just it's just one length. Okay. Let's just throw some numbers in here just for fun. See what we get. Okay. Watch. Let's make this. I don't know. 6. Okay. Let's make this one.
13.
Let's make it 14.
Awesome.
Okay. Now that's probably not twice as big, but it doesn't matter. It doesn't have to be to scale. What would this middle one be? What do we do to the top one and the bottom one? We add them up, right? And then do what to it? Right, divided by 2. Because if I add these up, right, and take half of it, it equals that mid-segment. So what's this one? It's 10. What if this? What if we did this? What if I didn't know this right here? What would I do?
You just have to figure out, well, 10 is half of the...
It's half of 20, right? So what do? We take double this then, right? So we double this, so we don't add a 6 to it. What do? So we subtract a 6. So it says 20 minus 6, which is what? 14. Now, there's a little bit on the kites that I didn't get to. If you really want to look at it, you could look at the book. Or you could look at first period's lesson. We did do the kite thing. It's not that long. It's pretty short. But let me put your homework up here, and then you can go. So it's section 6.6. I broke it up into 3 different chunks here. 8 to 11, 16 to 27, and 41 to 44. Okay?
What page?
440. So it's page 440 and 441. So there it is. Thank you.